In the previous video, we demonstrated the implementation of vector addition using both pinned memory and unified memory, and noted the difference in their respective execution times. In this video, we will explore how to calculate the execution time using heap events. While it is possible to measure the execution time of vector addition using timers or clocks in the host code, heap events provide a more accurate and reliable way to measure the execution time of GPU operations and help in identifying performance bottlenecks and optimizing code. Therefore, in this video, we will discuss how heap events can be created to monitor the execution of commands on the GPU and demonstrate how they can be used to accurately measure the execution time of vector addition operations. Heap events are one of the key features in heap that provide a mechanism for tracking the status of operations and monitoring the progress of their execution on the GPU. And heap event _t is a type used in heap programming to represent events. Heap events are used as a way to asynchronously record operations on the GPU. An event is created by calling the heap event create function. And then it can be used to record the start and end times of different operations such as data transfer or kernel execution calling the heap event record function. The event parameter in the function specifies the heap event to be recorded, and the stream parameter specifies the stream in which to record the event. The elapsed time between two events can be calculated in milliseconds using the heap event elapsed time function. The first argument ms is appointed to a floating point variable that will be populated with the elapsed time. The second argument start is the first event in the interval, and the third argument stop is the second event in the interval. The function returns the elapsed time between these two events as a floating point value in milliseconds, which can be stored in the variable pointed to by ms. Heap events are also used to synchronize streams together. Heap event synchronize event is a heap API function that blocks the host thread until the event is completed. This function ensures that all previous operations in the specified stream associated with the event have completed and the event has completed its work. This function can be used to enforce a particular ordering between events in different streams. The function heap event destroy releases the memory associated with a heap event. The argument event is the handle to the event that needs to be destroyed. The function heap event create with flags creates an event and allocates the memory for it on the device with the specified flags. The function takes as arguments a pointer to a event _t variable, which will hold the handle to the created event, and an unsigned integer that represents the flags. These flags can be used to customize the behavior of the event, such as indicating that the event should be recorded on a specific stream or indicating that the event should be recorded with a specific completion type. Heap device synchronize is a blocking function that waits for all GPU work to complete. This function can be used to ensure that all previous work on the GPU is finished before continuing with subsequent operations on the CPU. The function will block the host until all the operations in all streams are completed. Let's now take a look at some practical applications of heap events in code. This code measures the execution time of a GPU kernel in heap. We will demonstrate the utilization of events by recording them and calculating the execution time using the vector addition example we previously covered. We will look into the CPU code only, as the rest of the code will be the same as we worked on before. Let's look at the CPU code step by step. In the CPU code, after the CPU and GPU memory allocation and host array initialization, we declare a floating point variable GPU elapsed time ms that will be populated with the elapsed time. Next, two heap events of type heap event _t are created, start and stop, by using the heap event create function. These events are used to measure the time elapsed during the GPU computation. The data from the host memory is then transferred to the device memory using heap memcopy, just like what we did in the previous examples. And the block size and grid size is taken into consideration for further use in launching the kernel. In this block, the heap event record function is being used to record the start time of the GPU operation. Heap event record function takes two arguments. The first argument is the event to be recorded, which is of type heap event underscore t, the second argument in the stream identifier, which is of type heap stream underscore t. In this case, the second argument is 0, which is the default stream in heap. After that, the GPU kernel is executed with read and block size respectively. Finally, the stop event is recorded using heap event record function and synchronized with the host using heap event synchronize function. The results are then transferred back to the host memory using heap memcopy. This code calculates the elapsed time between the start and stop events using the heap event elapsed time function. The elapsed time value is stored in the variable GPU elapsed time ms. Finally, we print the elapsed time on GPU. As in previous example, we release the allocated memory on both CPU and GPU using heap free function and free function respectively. Finally, the main function returns 0 to indicate successful execution. Overall, events provide the basic features for us to profile the execution time of kernels, which is basic for performance analysis. As in later practices, we will continue to use heap events to measure execution time of GPU programs. In the next video, we will summarize this unit.